In a high-capacity operation, your spraying window isn't measured in days, it's measured in hours. And when you're managing 10 tons of high-speed leverage, a single component failure isn't just downtime, it's a $1 million risk. Most operators see maintenance as a chore, pros see it as an audit. Today, we're going deeper than any walk-around has ever gone. Every spec, every tolerance, and every engineering secret for the John Deere R-Series. I'm the real AG mechanic. If you want to keep your sprayer out of the shop and in the field where it belongs, you need to understand the physics of these machines. Welcome to the Technical Maintenance Masterclass. Chapter 1. Chassis Dynamics and Axle Geometry. The tread adjust system allows for variable row spacing, but it is the machine's primary structural vulnerability. Precision starts with your shim gaps. John Deere engineering specifies a maximum gap of exactly 60 thousandths of an inch. Anything beyond that allows the axle tube to rock inside the housing. In the field, that rocking becomes a hammer. Every bump translates into a vertical strike that creates a fatigue spike. Eventually, that hammer effect will literally punch through the bottom of your axle housing casting. The correction is surgical. Jack the machine to 0 weight. Torque the adjustment bolts to exactly 185 foot-pounds. This seats the brass shim pads perfectly against the steel tube. Then, back them off exactly 1/8 of a turn. This provides the necessary clearance for thermal expansion during high-speed transport while eliminating the destructive structural play. And stop using wet grease. In a dusty field, wet grease is just liquid sandpaper. Use a synthetic dry lube, Teflon only. It keeps the slides moving without attracting the grit that eats your shims. But structural integrity is only half the battle. Now let's talk about the heart of the drive system. Hydrostatic charge pressure. Charge pressure is critical. It keeps the hydrostatic loop full of oil, provides cooling flow, and supplies the pressure needed to shift the pump swash plates. At high idle, with the oil at operating temperature, you should be seeing between 350 and 400 pounds per square inch. If it drops below 200, you're risking cavitation and catastrophic pump failure. Filtration is your only defense. Replace these filters after the first 100 hours of a new machine and every 1,000 hours thereafter. This reservoir only holds 26 gallons. Keep it clean. Let's move to the wheel ends. The planetary reduction hubs are where the torque meets the ground and where heat meets chemistry. Let's talk hub metallurgy. Rear hubs run significantly hotter than the fronts. During transport, these gear sets can exceed 212 degrees. At those temps, Standard Oil loses its film strength and turns into an acidic slurry. Once the oil degrades, the gear teeth begin to pit. This creates more friction, more heat, and eventually leads to a bearing seizure that can lock a wheel at 25 miles per hour. Synchronize your hub oil changes with your engine oil. Every 250 to 500 hours, use a premium synthetic hub oil to manage the extreme thermal cycles. And remember the air pocket trap. Fill it, rotate it, run it, and recheck. Most hubs are left 10% low on oil because the air wasn't vented. That's 10% less cooling when you need it most. Know the difference between misting and failure. A faint oil film is normal after storage. A puddle is a failed seal. Don't wait for the hub to go dry. If it's dripping, pull it now. Chapter 3. Precision Application Electronics. The Exact Apply system is the industry standard for PWM technology, but its daisy chain architecture has a specific vulnerability. The most common issue is a sink line fault. Because these nozzle bodies are daisy-chained, a failure at nozzle 50 will take out every nozzle to the end of the boom. Every 750 hours, you need to pull the stems. Chemical residue buildup causes the poppets to stick, leading to erratic patterns and pressure spikes. Use the JDG 11925 test box to isolate the fault. If the box sees a 15 Hz signal from the inboard nozzle but the body stays faulted, replace the assembly. Check your O-rings for nicks or debris. Even a tiny flake of dried chemical can cause a nozzle to stay open, wasting thousands of dollars in chemical in a single afternoon. Now let's look at the 120-foot lever. The boom is an engineering marvel, but it's under constant fatigue from every bump in the field. The highest stress is at the center frame lift rack. If your boom isn't folding smoothly, don't just grease it. Check the inner pins for misalignment. Even a millimeter of play here translates to massive movement at the tip. Here is the mistake that keeps welding shops busy: the thrust washer. It must be on the bottom. If you put it on top, the steel section will wear directly into the casting. That's a permanent structural scar. Inspect your breakaway rivets daily. They are designed to be the failure point to protect the frame. If they're stretched or loose, your spray pattern is already compromised. Accuracy is profit. Chapter 4. Engine and Emission Life Cycle. The Tier 4. Final PSS engine is a clean-running beast, but you have to respect its regeneration cycles. When you see DTC 3719.16, a parked regen is required. Low idle, coolant above 140, and 20 to 40 minutes of your time. Don't forget the OCV filter every 1500 hours, and plan for ash handling at 5000. Ignore these alerts and the machine will derate, leaving you powerless in the middle of a job. Finally, let's talk about the R-Series primary thermal defense, the Extreme Cooling Package. When field dust meets moisture, it calcifies into a barrier that standard blowouts won't touch. Remove the side panels, just 2 bolts, to truly clean the core and protect your components. If you're seeing sluggish boom reactions, check your hydraulic relief pressures. Many R-Series sprayers need the software update to increase fan speeds and combat heat soak. And don't swap your pressure caps. The surge tank needs a 20 psi cap, while the overflow takes 8. Swap them, and you'll either blow a hose or vent your coolant way too early. CoolGuard 2 is excellent for 5,000 hours, but only if you test nitrite and pH annually. Chemically balanced coolant is the only thing protecting your cylinder liners. Every morning, drain your air tank. Moisture in the lines is the primary cause of valve failure and compressor seizure. It's a 10-second job that saves $3,000. But the most expensive mistake happens when the temperature drops. Let's look at the ExactApply winterization protocol. Drain the tank, clean every strainer, and run a full automated rinse cycle with John Deere Erase. Then, use the Boom Air Purge to clear the lines. The critical step for ExactApply, you must winterize both the A and B sides. Enable A+B mode in the cab to ensure antifreeze passes through every solenoid and passage. Use a non-toxic RV antifreeze. A standard ratio is 40 gallons of water to 5 jugs of fluid. This protects your system down to 20 degrees below zero. Don't forget the fence row nozzles. Manually activate them during the flush to ensure that protection reaches every valve on the machine. The difference between a machine that lasts 5,000 hours and one that fails at 1,500 is the discipline of the man in the overalls. Respect the specs, and they'll respect your bottom line. Charge pressure at 400. Shims at 0.060, hub oil every 250, ExactApply stems every 750. Follow the math, or the math will follow you. Uptime isn't a goal, it's a result. It's the result of technical precision, mechanical discipline, and the professional pride you take in your equipment. If you want to move beyond basic farming and into master-level agricultural engineering, subscribe to the Real AG Mechanic. Real specs, real info, maximum profit. I'll see you in the field.